are reaching maturity. Emerging from the aerospace and automotive industries, digital twin technology is now gaining popularity across sectors. The virtual replicas of real-world entities are used for comprehensive simulations, predictive maintenance, and virtual prototyping. But we're only scratching the surface. Let's peek into the future of digital twins. In 2025, digital twins simulate traffic flow in real time to optimize city layouts. Surgeons rehearse operations virtually before operating on patients. Manufacturers continuously monitor product quality during production processes. Retailers test and adapt layouts based on real-time customer interaction data. First responders model disaster layouts and optimize response strategies for better resource allocation. In 2026, digital twins optimize energy consumption in smart homes. Businesses anticipate supply chain disruptions and dynamically adjust logistics. Aerospace companies perform advanced simulations of aircraft performance under various conditions. Virtual replicas of water supply systems predict and prevent shortages and flooding. Athletes analyze performance and develop personalized training programs. In 2027, power companies use digital twins to integrate and manage multiple renewable energy sources. Wearable devices provide real-time health monitoring and advice. Digital models of historic sites are used to explore restoration options and predict the effects of weathering. Simulations of agriculture crop genetic modifications predict outcomes before actual cultivation. Organizations simulate network attacks to strengthen their real-world cybersecurity measures. In 2028, oceanic explorers map and simulate deep-sea conditions for safer and more fruitful missions. Cities integrate digital twins into their public safety networks to enhance crime prevention and response strategies. Pharmaceutical companies simulate responses to new medications before human trials begin. Construction projects are streamlined with the ability to detect potential issues earlier than ever. Event planners simulate, manage, and optimize traffic flow with real-time data during large public events. In 2029, governments use digital twins to simulate and plan for different climate change scenarios. Tourism agencies offer simulation previews of vacation spots. AI-driven digital twins analyze and optimize urban waste collection and processing systems. Utilities companies predict demand spikes and improve electricity distribution efficiency. Retailers optimize delivery routes in real time to improve customer experience and reduce costs. In 2030, digital twins create dynamic, personalized learning experiences that adapt to student performance and engagement. Fleets of autonomous vehicles use digital twins to ensure safety, efficiency, and integration with public transportation systems. In retail settings, advanced digital twins predict consumer behavior and optimize inventory dynamically. Fully automated production lines require minimal human intervention thanks to real-time monitoring and predictive maintenance. In 2031, digital twins are used in major infrastructure projects to optimize design and monitor construction in real time. Space agencies use digital twins to simulate environments for astronaut training and mission planning. Governments model public health scenarios, including virus spread, hospital capacity, and the impact of interventions. Integrations with robotics and industrial automation systems tighten, with digital twins performing complex tasks in unpredictable environments. In highly regulated industries like finance and pharmaceuticals, simulations of business operations ensure compliance amid evolving global regulations. In 2032, digital twins simulate pharmaceutical behavior at the molecular level to predict outcomes in nanomedicine. Models of complex weather systems deliver precise, real-time forecasting and disaster readiness in regions prone to extreme weather. Law enforcement agencies recreate crime scenes virtually for detailed analysis without compromising investigation integrity. Human-machine interactions are enhanced with digital twins able to mimic human cognitive responses. In materials science, digital twins predict the behavior and lifespan for applications like biodegradable products and self-healing materials. In 2033, digital twins oversee urban farms with AI adjusting conditions for optimal plant growth. Virtual reality models of real estate properties enable potential buyers to explore properties in a fully immersive experience before purchasing. Augmented reality for ancient structures emerges with digital twins guiding maintenance efforts of the world's earliest known structures and historical sites. In 2034, emotionally responsive buildings emerge, with digital twins adjusting lighting, temperature, and even wall colors to suit the moods of occupants. Digital twins are used in sleep studies to analyze and optimize dream patterns, improving mental health and creativity during sleep. Personal fashion avatars try on and display clothing in virtual spaces, giving style advice based on trends and personal habits. Plant communication systems interpret plant health and needs, translating them into verbal communication for gardeners. Interactive movie experiences customize characters and storylines in real time. Digital twins that capture and recreate moments in time allow people to revisit the past like never before. In 2035, digital twins of medical patients enable real-time monitoring and tailored treatment plans. Real-time simulation of natural disasters provides predictive analytics to optimize evacuation routes and emergency responses. Museums offer immersive experiences simulating time travel, with patrons witnessing historical events. The need for human attorneys is reduced with automated legal advisory services that use digital twins to simulate legal scenarios. In 2036, space agencies design missions, simulating spacecraft and crew interactions with extraterrestrial environments to ensure safety and mission success. Digital twins of individual brain functions and pathologies brings personalized neurological treatments and preventative care. Insurers offer dynamic pricing based on actual usage and risk profile of assets like cars, homes, and industrial equipment. Manufacturing processes across multiple factories are interconnected, enabling real-time adjustments and optimizations based on global supply and demand. In 2037, digital twins simulate the outcomes of genetic modifications in crops and livestock, predicting long-term effects and optimizing genetic engineering. By modeling the interaction between body tissues and prosthetic devices, digital twins improve the design and functionality limb replacements. Simulations of life support systems and environmental conditions in space colonies provides crucial data for building sustainable civilizations on other planets. In 2038, citywide digital twins dynamically manage public transportation systems, adjusting routes and schedules in real time based on user demand and traffic conditions. Entertainment platforms create highly personalized content based on viewer preferences and reactions. Digital twins of historical sites allow for interactions that are not possible in the physical world. By monitoring the life cycle of materials used in manufacturing, digital twins predict when materials will fail and suggest alternatives. In 2039, digital twins provide real-time, situational overlays helping individuals make better decisions in their personal and professional lives based on simulated outcomes and historical data. Simulated resource management scenarios for human settlements on the Moon or Mars optimize the use of local resources and support systems. Law enforcement agencies simulate and predict crime patterns, enabling authorities to intervene preemptively. Digital twins modeling AI behavior in complex scenarios helps ensure ethical decision-making, transparency, and compliance. In 2040, digital twins fully control smart cities, from traffic to waste management to energy distribution. Integrations with genomic data facilitates personalized medical treatments and preventative medicine. Digital twins serve as testing and development platforms for AI systems, enabling simulation of real-world environments and interactions without associated risks. Virtual reality sports enter maturity, with digital twins creating personalized training environments and tailored fitness programs. In 2041, digital twins pair with quantum computers to optimize complex systems like traffic networks and financial markets. Digital twins enable deep-sea and subterranean exploration with real-time data and scenario simulation. Integrations with next-generation renewable energy systems optimize energy flow and storage based on real-time supply and demand data. Modeling wildlife and natural reserve areas unlocks precision conservation efforts, including reintroducing species and habitat management. In 2042, digital twins manage and optimize agricultural systems on Mars, simulating plant growth in extraterrestrial soils under controlled environmental conditions. Media outlets create hyper-personalized content, adapting movies, books, and games in real time to individual emotional responses and preferences. Smart nanotechnology advances, with digital twins controlling nanobots used in medical treatments and environmental cleanup. In 2043, digital twins extend virtual reality to provide full sensory experiences, allowing users to see, hear, touch, and even smell virtual environments. Advanced simulations and predictive maintenance for spacecraft ensures long-term functionality and safety during missions. Using historical data and real-time feedback, digital twins simulate and predict crime so authorities can deploy resources more effectively. Surgeons are equipped with real-time visuals and predictive analytics to improve outcomes and mitigate risks during procedures. In 2044, digital twins enable telepathic interfaces that translate brain activity into digital communication. Personal digital twins compile and recreate detailed simulations of an individual's life experiences. Simulations of ethical dilemmas provide reasoned solutions based on a vast database of legal and philosophical outcomes, assisting in decision-making and AI governance. In 2045, digital twins manage entire eco-cities, optimizing resources to adapt to population dynamics and environmental changes. Remote collaboration is taken to a new level with holographic workplaces that reflect physical office spaces. Digital twins simulate and manage interstellar navigation systems for space travel. Artists produce dynamic works that change and evolve based on viewer reactions with dynamic artistic expression platforms. In 2046, digital twins integrate with neural implants to enhance human memory recovery. Virtual reality evolution therapy uses digital twins to simulate evolutionary changes, helping people adapt to future environmental and societal shifts. Digital twins monitor and regulate nano-ecosystems, balancing microorganism activities for health, agricultural, and environmental applications. In 2047, digital twins manage ecosystems on other planets, adjusting conditions to support terrestrial life for future space colonization efforts. Interactive ancestral archives allow people to explore their lineage in virtual environments with realistic simulations of historical contexts and lifestyles. Digital twins simulate properties of new materials at the atomic level, accelerating the discovery and development of next-generation materials with novel properties. In 2048, digital twins in industrial settings continuously experiment with new manufacturing processes, materials, and designs to accelerate innovation. Sleep devices interface with digital twins to record, interpret, and even change dreams in real time. Memory editing facilities emerge. People can safely explore and alter their own memories. In 2049, advanced digital twins emulate entire human brains, bridging biological and artificial intelligence, a possible step toward digital immortality. Digital twins manage symbiotic ecosystems with humans, technology, and nature coexisting seamlessly in urban settings. Autonomous interstellar probes adapt and respond to unforeseen cosmic phenomena. Otherworldly simulation and predictive analytics extend humanity's reach into deep space. In the 2050s, digital twins manage complex neural interfaces, allowing for direct brain-to-computer communication. By 2060, digital twins operate at the quantum level to bring new forms of computing and energy systems. In the 2070s, they design and monitor synthetic organisms to perform specific environmental or industrial tasks. Cognitive expansion emerges in the mid-2080s, using virtual twins to expand human cognition. That opens the door for mankind's most profound innovation yet. In the 2090s, digital twins facilitate communication with alien life, decoding and translating messages effectively. With big help from digital twins, humanity's most profound questions are about to be answered.